Welcome guys to the 4.1 continued video for our circular motion problems. I'm going to do 4 quick examples that will be very similar to the Delta Math problems that you're going to do. So we're going to have 4 problems. So let's see if we can knock these out. The radius of each wheel of a car is 9 inches. If the car is traveling at 70 miles per hour, how many revolutions per minute are the tires turning? So what we want is to make sure, I'm going to put on my pen, what we want to make sure of is when we start the problem, we have to be given a certain rate to start. And as you can see, we are traveling at 70 miles per hour. So that is how we're going to start the problem. 70 miles per 1 hour. Now, we're going to do a bunch of calculations. And at the end, though, what is the rate that we want? We want to know how many revolutions per minute. So that means we want revolutions in the top and minute in the bottom when we're all said and done. So we know we're going 70 miles per 1 hour. How do we change that to minutes? Well, we have to know basic conversions here. We know that 1 hour is 60 minutes. Now, some of you are like, how do I know which one goes on top, which one goes on the bottom? Well, we wanted minutes to go on the bottom to match up with the minutes that we wanted for our answer. And we now can see that hour is going to cancel out. So now we have to do some more conversions. Now, the wheel comes into play here. And by circumference, we know that 1 revolution for circumference is either pi times the diameter or 2 pi r. Now that depends on what we're given. We have the radius of each wheel is 9 inches. So we're going to use this one. So we're going to have 2 pi and then r was 9 inches. So that helps us get revolutions on top, but now we still have miles and inches we have to convert. All right, so we know that there are 5,280 feet per 1 mile. Get rid of that. All right, so I know that mile is going to cancel, but now I still have feet and inches. All right, well, we know that there are 12 inches per 1 foot. And again, I put the 1 foot on the bottom so that these cancel and then inches cancel. Now, as you can see, what we're left with is the units that we wanted. We wanted revolutions per minute. So now what we want to do is we want to get out our calculator and we want to be able to type all of this in. All right, so remember that the easiest way to do this is I'm going to go alpha F1 and I'm going to make my fraction. And I'm simply going to type all the numbers multiplied in the top. So I'm going to have 70 times, I'm not going to do 1 because 70 times 1, and then I'm going to do 5,280 times 12. And on the bottom, I'm going to have 60 times 2 pi. Pi is above the caret there. Times 9. And that's it. And then there's my answer, that how many revolutions per minute for a car tire is going to wind up being 1,307.193. So that winds up being our answer for all of our conversions here. Okay, let's do another one. The diameter of each wheel of a monster truck is 10 feet. If the tires are turning at a rate of 2 revolutions per second, how fast is the truck going in miles per hour? So the end of this, we want miles per hour. At the beginning, we have to find a given rate, and this tells us it's turning at a rate of 2 revolutions per second. So we're starting at 2 revolutions per 1 second. All right, so what else do we know? The diameter is 10 feet. Now, we know that 1 revolution is the circumference. So I am going to put 1 revolution on the bottom to cancel. And again, we're going to use 2 pi r or pi d, depending upon what they told us about the wheel. They told us we had the diameter. All right, so I'm going to use pi d for the diameter. So I'm going to have pi times 10 feet. All right, so what else do I need to know? I have seconds and I need hours. All right, so let's see. I know that 60 seconds is 1 minute. That gets the seconds out of there. I also know that 60 minutes is 1 hour. So I can cancel that. That gets me hour where I need it in the bottom. Now, what about the miles on the top? What do I have? I have feet. So again, another popular one. We know that there are 5,280 feet for 1 mile. So that tells us the feet are canceled. And then if I look, I have what I want. I want miles per hour. So I have the units I want. When you have the units you want, go ahead and multiply it out and you'll get your answer. So I'll bring my calculator back up and I will look here. And very similar to the last one, I'll go alpha F1, bring up my fraction. On the top, I'm going to have 2 times pi times 10 times 60 times 60. On the bottom, I'm going to have just 5,280. 5,280. And then I'll hit enter, and that will tell me that in miles per hour, that monster truck is going about 42 miles, almost 43 miles per hour. So 42.839 or 840 if we're rounding to 3 decimal places. Okay, let's look at another one. The Ferris wheel at Cedar Point is 64 feet in diameter. You measure that it takes 90 seconds for 1 full revolution. What is the linear speed in feet per second of the Ferris wheel? All right, so at the end, we want feet per second. All right, what else? So we measure that it takes 90 seconds for 1 full revolution. So we can say 1 revolution takes 90 seconds. That's our given rate there. All right, so the good thing is we already have seconds in the bottom. So that's good. All right, now we got to get that revolution out of there and we got to somehow come up with feet. So again, one thing that always shows up is that we have the circumference of being 1 revolution. So I know that 1 revolution now, again, am I using pi times the diameter or 2 pi r, depending upon what they gave us? So the Ferris wheel at Cedar Point has 64 feet in diameter. All right, so I'm going to use pi d. So pi and then 64 feet. That gets the revolutions out of the way. And then, I'm actually done. Look at this. I've got feet and I've got per second. So this one is actually a short one. So all I have to do here is pull up and make my fraction. On the top, I'll have pi times 64 over 90. And this tells me then that I will wind up with the Ferris wheel turning at 2.234 feet per second. Okay. All right, we'll do one last one. Jeff is flying his jet around the world. Well, good for Jeff. His jet is on average 3,978 miles from the center of the earth. If Jeff is going 420 miles per hour, assuming he has unlimited fuel, how many revolutions of the Earth could he make per week? Oh, wow. Okay, so we're going to try to find now the number of revolutions per week. All right, so what do you think the given rate was? It says right there he's going 420 miles per hour. So we're going to start with 420 miles per 1 hour. And so now we know, I got to think about a couple things here because we need the week. Now, one revolution, again, is going to be in terms of either radius or diameter. Now, he's telling us the jet is on average almost 4,000 miles from the center of the Earth. So that is a radius. So I am going to use 2 pi r, which is then times 3,978, and that's miles. Okay, so that actually helps us get rid of the miles. And then I got to get rid of hours. So now we got to think of some basic science stuff here now. I know that when the Earth turns, right, that there are, 24 hours per 1 day. So that helps us get rid of the hours. And let's think of something else here now, because I got revolutions on the top and I got day down here. So how many days for 1 week? So 1 week is actually going to be 7 days. So now that gets rid of the days, and I have week and revolution. So I actually have what I need now. So now I can go ahead back to my calculator and multiply this out. So I'll make my fraction alpha F1. On the top, I'm going to have 420 times 24 times 7. 24 times 7. On the bottom, 2 pi times 3,978. And that's it. So Jeff makes at least 2.823 revolutions per week around the Earth. So there was 4 quick examples of those circular motion problems. Hopefully that'll help you with the Delta math. And thanks for tuning in.